Uh, Good evening, everyone. My name is Kita Irina Lasmi, student ID 25 of 14555 from the Oil and Gas Logistics Study Program. Today, I will present the result of our field observation analysis entitled Integrated Oil and Gas Logistic Operation. This presentation focuses on downstream logistic activities observed at several important operational facilities, namely the fuel terminal, Aviation Fuel Terminal, or AFT, LPG Depot, and Lube Oil Blending Plant. During the observation, we learned that downstream oil and gas logistics is far more complex than simply transporting fuel products from one location to another. Behind every fuel distribution activity, there are integrated systems involving transportation planning, storage management, quality control, safety monitoring, inventory management, and last operational coordination. One insight from this observation is that even a small operational error, such as contamination, unstable pressure, inaccurate measurement, or delayed transportation, can affect the continuity of national energy supply. Therefore, precision, discipline, and operational reliability are extremely important in the oil and gas logistic industry. So next, integrated oil and gas logistic operation. Integrated oil and gas logistic operation refer to a connected operational system that manages petroleum products from refinery production until final delivery to consumer. This integrated system includes receiving operation, transportation, tank storage management, quality inspection, blending activities, loading system, and final distribution. Based on our observation, each facility has different operational responsibilities. First, fuel terminal focus on bulk fuel storage and high volume distribution. Two, aviation fuel terminal prioritize aviation fuel quality and aircraft safety. Three, LPG depots manage pressurized gas handling system. For the last, Lube Oil Blending Plants focus on lubricant production and formulation precision. What makes this logistic system interesting is the integration between facilities. Products continuously move through pipelines, tanker vessels, hydrant systems, tanker trucks, and automated filling system. This means logistic performance isn't only measured by delivery speed, but also by product integrity, operational safety, supply reliability, and distribution efficiency. Another important insight is that downstream logistic operations operate almost continuously for 24 hours because national energy demand is extremely high and cannot tolerate long disruption. And three, next, introduction. So about introduction, we gonna we gonna we're gonna show in this presentation downstream logistic involves transportation, storage, processing, and distribution activities required to deliver petroleum products safely and efficiently. However, operationally, downstream logistics is considered a high-risk industry because petroleum products are flammable, pressurized, and environmentally sensitive. During the observation, we identified three major operational priorities. First is self-delivery. Every operational activities follow strict HSSE standards, which stand for Health, Safety, Security, and Environment. Operator, Operators use operational protective equipment, grounding system, gas detector, emergency shutdown system, fire protection equipment, and leak prevention system to minimize operational risk. Second, efficiency. Operational efficiency is very important because delays during loading or unloading activities can affect fuel availability in multiple regions. Facilities monitor turnaround time carefully to ensure distribution activities run smoothly and continuously. Third is sustainability. Environmental compliance is becoming increasingly important in modern logistic operations. Facilities implement spill prevention systems, vapor recovery system, wastewater treatment system, and emission control programs to reduce environmental impact. One interesting insight is that many downstream facilities are now adopting digital monitoring system and automation technology to improve operational feasibility and reduce human error. So next, that is objectives of observation. The objective of this field observation wasn't only to observe operational activities directly, but also to understand how integrated logistics systems work in real industrial environments. There were four main objectives during the observation. First, understanding the end-to-end logistic process. We studied how petroleum products move from refinery facilities to storage terminal and finally to consumer. Second is observing operational activities. We observe operational equipment such as storage tank, pipelines, loading system, filtration system, hydrant system, and blending equipment. Third, analyzing supply chain integration. We analyze how different facilities coordinate to maintain stable energy distribution for gasoline, diesel, jet fuel, LPG, and lubricants. Fourth, identifying safety and quality control system. So we reviewed laboratory inspection, emergency system, leak prevention procedures, contamination control system, and operational safety protocols. An important insight from this observation is that operational discipline and communication between divisions are critical for maintaining supply chain reliability and preventing operational disruption. So next, integrated logistic flowchart. This flowchart explains how integrated logistic operations are connected from upstream production facility to downstream distribution system. The process begins at refinery or production facilities where petroleum products are produced. After production, products are transported through pipelines, tanker ship, railway system, or tanker truck, depending on operational requirements and geographical conditions. The products are then stored in facilities such as fuel terminal, AFT facilities, or LPG depots. Some products continue into processing stage, such as lubricant blending operation in the Lube Oil Blending Plant. Finally, products are distributed to gas stations, airport, industrial consumers, household and transportation sector, and commercial users. One interesting operational insight is that uh, synchronization between facilities is extremely important. Delays in transportation, storage elimination, or equipment failure can affect the entire supply chain network and disrupt energy availability. So next, slide 6, fuel terminal operation. Fuel terminal function as the primary storage and distribution hub for fuel products such as gasoline, diesel, and biodiesel. Operationally, the process starts with the fuel receiving from refinery pipelines or tanker vessels. Before product enter storage tanks, fuel samples are tested in the laboratories to verify density, temperature, water content, and the contamination level. This quality inspection process is extremely important because contaminated fuel can damage engines, reduce combustions performance, and disrupt distribution operation. After inspection, products are transferred into a large capacity tank farms equipped with automatic level indicators, temperature sensor, pressure monitoring system, and emergency shut-off valve. One operational activity that attracted our attention was the loading sheet process. Before tanker truck enter loading areas, operators perform strict safety inspections, including grounding, cable check, vessel condition inspection, document verification, and emergency equipment inspection. Another interesting insight is that fuel terminal maintain buffer stock system on to anticipate supply disruptions caused by weather conditions. transportation delays, equipment maintenance, or sudden increases in fuel demand during national holidays. This demonstrates this demonstrates how fuel terminals play a strategic role in maintaining national energy security. Next, about Aviation Fuel Terminal. The Aviation Fuel Terminal supplies Jet A1 fuel for aircraft operations and applies stricter operational standards compared to regular fuel distribution facilities. Aircraft engines are extremely sensitive to contamination, which is why aviation fuel handling requires very high precision. During the observation, we found the aviation fuel passes through multiple filtration straight to remove water, particles, and impurities before distribution. Then the facility also conducts laboratory testing tests on international GI, GIG standards to ensure fuel quality and safety. Another interesting operational feature is the hydrant system. Instead of relying only on tanker trucks, some airports use underground hydrant pipelines connected directly to aircraft parking areas. This system improve operational efficiency, reduce visual congestion, and accelerates aircraft turnaround time. Operators also conduct bonding and grounding procedures during refueling operation to prevent static electricity, which could potentially trigger ignition. One important insight from this observation is that AFT operation apply the principle of zero tolerance for contamination, because even every small impurities can compromise aviation safety. Next, we talk about LPG depot operation. LPG depot operation are highly focused on pressure management and gas safety system. Unlike liquid fuels, LPG products are stored under high pressure inside spherical tanks to maintain them in liquid form. During the observation, we noticed that pressure and temperature monitoring system operate continuously because change in temperature can significantly affect gas pressure stability. The cylinder filling process uses automated carousel system capable of filling hundreds of cylinders efficiently while maintaining filling accuracy. Before cylinders are distributed, leak testing procedures are conducted using immersion methods and gas detection system to ensure product safety. One interesting operational insight is that LPG depots must maintain a very high emergency response reading because gas leaks can spread rapidly and create fire or explosion hazard. This explains why safety distances, emergency shutdown system, and fire suppression system are extremely important in LPG operation. So next, Lube Oil Blending Plant. The Lube Oil Blending Plant products lubricant through controlled blending operation. The production process starts with base oil receiving and additive storage. Additives are chemical compounds used to improve lubricant performance characteristics such as anti-wear protection, viscosity stability, corrosion resistance, oxidation resistance, and temperature durability. The blending stage uses automated system to ensure formulation precision because even small formulation errors can affect lubricant quality and engine performance. So after blending operation are completed, laboratory testing is conducted to verify viscosity, flash point density, and chemical stability. The final stage involves automated filling, is packaging, labeling, and distribution. One interesting insight is that lubricant products are highly customized. Different formulations are the produced for motorcycle, passenger vehicles, industry machinery, marine engines, and heavy EV equipment. This means that LOBP operation combined logistic management, manufacture system, chemical engineering, and quality assurance within on the integrated process. So next, we talk about facility comparison metric. We're gonna talk about this compression metric explain that operational difference between each downstream facility. Fuel terminal prioritize throughput volume and bulk fuel storage efficiency. Aviation fuel terminals prioritize storage qualities, control system, and advanced filtration technology. LPG depots focus heavily on pressure control, system and gas safety management. Meanwhile, Lube Oil Blending Plant prioritize formulation accuracy and manufacturing precision. All two facilities are connected within the same supply chain network. Each facility faces different operational risks, technical challenges, and performance priorities. This comparison demonstrated how integrated logistics system require multidisciplinary operational management. Next, we're going to talking about key logistic challenges. There are several major challenges in oil and gas logistic operation. First is safety hazard. Petroleum products are highly flammable and can create fire or explosion risks if operational procedures are not followed correctly. Second is product integrity. Maintaining fuel cleanliness and preventing contamination are extremely important because contaminated products can damage engines and equipment. Third is inventory control. Facility must maintain sufficient buffer stock levels to prevent supply shortages during operational disruption. Fourth is transportation scheduling. Operators must coordinate tanker trucks, pipelines, diesel, and loading system efficiently to avoid delays. Fifth is asset integrity. Operational equipment, such as tanks, valves, pump, and pipelines, require regular maintenance and inspection to prevent failures. Six is environmental compliance. Facilities must comply with strict environmental regulation regarding emissions, spills, and waste management. One important insight is that logistic failures in the energy sector can directly affect public transportation, industry productivity, efficient operation, and national economic activities. Why integrated logistic matters? So, integrated logistic systems are extremely important because they ensure a continuous energy availability with high safety standard. Efficient logistic operation help reduce operational costs, minimize delays, optimize inventory levels, and improve supply reliability. In Pertamina's downstream operation, integrated logistics system also support national energy security by ensuring fuel product remain available across Indonesia, geographically challenging regions. This slide highlight an important operational principle. Energy distribution system must achieve maximum availability with minimum safety compromise. Another interesting insight is that digitalization and automation are becoming increasingly important in integrated logistics system because they improve operational visibility, data accuracy, and decision-making speed. Okay, next is conclusion. In conclusion, integrated oil and gas logistic operation play a critical role in supporting self-efficient and sustainable downstream energy distribution. From this field observation, we'll learn that every facility has different operationally responsibilities, technical system, and safety. However, all facilities are interconnected within one integrated supply chain network that supports national energy distribution. We also learned that operational discipline, quality control, staff management, logistic coordination, and technological integration are essential for maintaining reliable energy supply system. This field observation provided a valuable insight into how complex that strategic downstream oil and gas logistic operations truly are. Strategic recommendation. Based on our observation, there are several strategic recommendations that can improve logistic performance. First is increasing automation system. Facilities should continue improving digital monitoring system, automated inventory tracking, and real-time operation data integration. Second is strengthening HSSE culture. Continuous training, emergency simulation, and operational discipline are important to maintain workplace safety. Third is supply chain optimization. Optimization. Improving transportation scheduling and distribution planning can reduce transit time and operational bottlenecks. Fourth is green logistic implementation. Facilities should continue implementing environmentally sustainable practice such as emission reduction system, energy efficiency programs, and waste management improvement. An important insight is that future oil and gas logistic operation will increasingly depend on digitalization, automation, and sustainable strategies. So, thank you for your attention. That is all that is all for my presentation about integrated oil and gas logistic operation. I hope this presentation provides us with better understanding about how downstream energy logistic system operate in real industrial environments and how important operational integration is for maintaining a national energy supply reliability. I would be happy to answer your questions. So bye bye.